In this video, we are going to create an image classification project with the help of training the data with convolutional neural network. So convolutional neural network is one of the important concepts in the deep learning, which is highly used for the image classification. Why it is demanding means compared to other neural networks like recurrent neural network and artificial neural network, the CNN is pretty accurate. So only the most of the people are using the convolutional neural network for the industries projects and research and development fields. Generally in deep learning, there are two types of problems are present. The first one is the classification and second one is the regression. In this video, we are going to solve the classification problem using the convolutional neural network. So again, the classification problem is divided into three categories that are the binary classification, multi-class classification and the multi-label classification. So start from the first. The binary classification means result will be either the yes or no type of determination. This video is also comes under the binary classification technique. So we are having the data set here which contains two labels. The first one is the images with mask and second one is images without mask. With this data set, we are going to predict if the people are wearing the mask or not. So this is what the binary classification is. There are some other techniques like multi-class classification and multi-label classification. I will explain those concepts on separate video because it will take more time to explain. If you want the multi-class classification, then go and check this video. I explained the multi-class classification with some clear-cut examples and code. But in that video, I did the project on the normal neural network. It is not worked with the CNN. I will upload these two classification techniques soon with the implementation of the convolutional neural network. Okay, so this video is related to the binary classification only. I don't want you to confuse with explaining the other concept with that. So we have a lot of time and definitely I will make a projects related to the multi-class and the multi-label classification techniques. Okay, so this is the introduction part. Before we do this project, make sure you need to understand the working progress of the CNN. It is very important to understand the CNN algorithm. You know, it is a powerful algorithm. You can implement this algorithm on various projects and definitely it will give you the accurate results. So once you understand this algorithm completely, then your machine has acquired some superpower to classify any objects in the world. There is a lot of mathematics behind every layer present in the neural network. I am going to explain this math concept very clearly, so watch this entire explanation till the end. Otherwise, you will not able to understand the coding part. So let's start this video. If you want to form a convolutional neural network, then you need these three important layers. That are the convolutional layer, pooling layer and fully connected layer. Basically, if you are having the image and if you want to classify the image, the machine can read that image through the matrix formation. Every image is a combination of red, green and blue colors. So we can say it is a 3-channel images. So in convolutional layer, there is one process called feature mapping. So it is a very important thing. Using this concept, the machine can understand which image is this. I will give you one quick real-time example. You can easily understand what this concept is. Okay. So note that it is a straightforward explanation. It will make you to understand the CNN more easily. Here I have one image. There is a lot of features are present in this image. Here the features are the eyes, hair and mask of Elon Musk. We are going to map the mask feature that are present in the image. For extracting the feature, we are going to use some filters like mask detection filter. We are going to extract this single feature from this image. So in this project, we are going to detect only the person with mask or not. We are not going to recognize the images. In case of image recognition, you have to map all these important features in the feature map. In the image recognition, the convolutional neural network will split this image into multiple categories and apply the feature detectors to map the features in the matrix. So this is the process of the image recognition with the mask detection. Okay. Now look at this matrix. You can consider this matrix is a image value matrix and then this layer will apply the mask detection filter into this image matrix. The mask detection filter is nothing but it is a one kind of matrix. That matrix is abstracted one. We are not able to see its operations while doing the code. The interesting thing in the neural network is it automatically generates filters. There is a math behind that. I don't know how it works behind. I searched about the solutions on online, how the filters are chosen. Mostly I get the answers like it will choose the filters automatically based on your image. I'm not agree with that statement. So if you have any statement about that, comment down yours, then we can learn from yourselves. But you should know about what they are performing inside the code. Here the image matrix is present and it will get multiplied with the mask detection filter. So this filter identifies the mask bearing area that present in the image. So after we process with this filter, you will get this type of feature map. Here you can see the matrix which contains the mask feature. This is how the feature mapping will happen in the convolutional layer. There is another case. Sometimes you can face a different type of data like inverted picture or improper mask alignments. So the CNN will handle all the variety of data and it will give you the feature map by identifying those mask features of the data. If it is in the improper position, the CNN doesn't care about that and it will identify the feature from the image without any mistakes. So that is a special thing about the convolutional neural network. Okay. So next parameter in the convolution layer is the activation. One of the popular activation method is ReLU. We already discussed about the ReLU in the image recognition deep learning project. ReLU is nothing but if there is a non-linearity present in the matrix, the ReLU method will make into the linear one. Suppose you are having this matrix value. Here we detected the feature of Elon Musk image and you can see some negative values will make this matrix a non-linear one. And if we apply the ReLU activation, then it will go to the negative value and make them as a 0. So why we are doing this means it will reduce the errors in the computation while performing the calculations. So this is the thing, the ReLU activation works in this convolutional neural network. Okay. So next layer is the pooling layer. This layer is pretty simple. So when you are having the large image dimensions, then your machine takes so much time to compute all the pixels. In order to reduce the dimensions, we are using the pooling layer here. There are three types of pooling mechanisms. The first one is the max pooling, second one is the average pooling, and final one is the sum pooling. We are going to use the max pooling here. The max pooling is nothing but we already have the convolutional matrix, right? Max pooling will reduce that matrix dimensions. So the reduction of matrix will depend on how much number of strides we are going to use. So this is our matrix. Here I applied the stride number 1. Just watch this step carefully. So it is very important step in the max pooling layer. Here we selected 4 cells. The max pooling layer will select the maximum element from the selected cells and put them in a new feature map. So this is the process of the max pooling layer. I will give you some examples. So here we are having the 4 selected numbers and this layer chooses the maximum number that present in the selected cells and then it forms a new feature map. So this is the process of pooling layers in the convolutional neural network. And the final one is the fully connected layer. That's a pretty straightforward to explain. So in the FC layer, we need to add the function called flatten. This flatten function, it converts your matrix into single dimension. So we must add the flatten layer in the every neural network U forms. Because making the arrays flatten, it is very easy for the computation and it is very easy for the neural network to process your images. Okay. Next, we need to add how many number of neurons we need to fire initially. So you have to give some number for the neurons. After that, they will process the images and they will give you some weight about the data. If you want the explanation of how the neurons are working, then go and check this video. That will be very helpful to understand this concept. Next, we need to add the last dense layer that is used for determining the output. In this case, we are going to get only 2 type of results, either true or false. So you need to give the value 1 to this dense layer. Here you need to give the activation. If you are using the binary classification technique, then you have to give the sigmoid value to the activation. So this is the theoretical explanation of the convolutional neural network. I talked so much about that. Let's start the coding part. In the Jupyter Notebook, I imported some of the important libraries and modules for performing this project. So you all know about this. Basically, we are using some familiar libraries in Python which are highly used for implementing the deep learning approaches. Okay, so I skipped the explanation here. Before we start the training process, I want to show you some images which are from the dataset. I downloaded the dataset from one GitHub repository. It is nearly 70 megabytes. I will share this dataset in the Telegram. You can easily get that dataset from my Telegram channel. You can see this is our sample image from the mask detection dataset. So you already know about this. We are having 2 labels. The one is with mask and the other one is without mask. I want to show you how the dataset actually look like. So you can see this is my dataset here. There are 2 folders are there. One is for training and the other one is for testing. When you open that training folder, you can see the another 2 labels which contains some images with mask and without mask. I don't know how many data present in the training dataset. So we can easily find that while doing the code. That is not a very big deal. Okay. So now we need to normalize the data. Normalization means we are going to divide the image pixels with 255. Why we are dividing the image pixels with 255 means all the images have 3 channels that are red, green and blue. So 255 is the limit of every color value. If we add the 255 with every image value, then you will get a normalized image matrix value. So it is easier for the computation and there will be a less chance of getting the errors and overfitting results. So that is the reason for the normalization. Here I typed the code for two separate data with the help of image data generator class. Next we are going to store the data in separate variables. Here I created one variable that is the train dataset. I used one method called flow from directory. In this method I mentioned the data directory and also I added some few parameters. So I will explain how the parameters are working here. Okay. So here the second parameter is the target size. Basically it will reduce the size of every image in the dataset. Suppose you are having the uneven image dimensions, so it is hard to form a matrix and it is hard to compute for the neural network. If all dimensions are in the even size, then there is no problem, we can easily process the images. Okay, so that is why we are adding this parameter. Okay, and the third parameter is the batch size. Batch size is nothing but it will allow the data samples in one iteration for training purpose. Here we assigned 16, so 16 set of data samples will go for the training from the data set. Now the last parameter is the class mode. It says how many categories you actually have. In this case we are having two labels that are the data with mask or without mask. So we included the binary class mode here. So this is for the training data set. You need to create another variable for testing side. So just copy this step and follow the same process that you did in the previous one. You can see how many images are present in the training and testing folder, and that's all about the pre-processing. Now we need to create the neural network. First I type the code and then I will explain the code. Okay. I created three set of feature extraction layer for this program. Actually, you can add multiple number of feature extraction layers. In case of CNN, you need to add at least 2 layers for the feature extraction. But here we added 3 set of layers for the feature extraction. That is not a big problem. It will always increase your computation and your accuracy. So the rest of the parameters like the activation and flatten function, I already gave the detailed explanation about them in the theory section. Now we need to compile the model. Here I wrote some codes and I inserted some parameters. These parameters are nothing but it will help you to tune the model performances. My first parameter is the optimizer and second one is the loss function and third one is the evaluation of accuracy. These three parameters are very important. Each parameter holds some formulas behind it. When you know the formula, then it is easy to understand. These things need a separate video to explain. So I will give you some theoretical explanation about this. For the formula explanation, I will explain it in a separate video. Okay, so the optimizer here we added, it will help you to analyze the learning rate of the algorithm. And in the last function, we added the binary cross entropy value. So we are having two labels, right? First one is with mask and second one is without mask. So it will analyze the loss while predicting these labels. So this is the main function of this parameter. And finally, the metrics parameter is used to evaluating the accuracy of the model. Okay, so that's all about the code. Let's start the training process. So here I go for the 7 approaches. That will be enough for the training. Let's run this code. You can see here we trained our model successfully and let's do the prediction. In the test dataset there are 194 images are present. Here I am going to predict the 190th image in the test dataset. You can see I get the value as 0.9. Actually it is close to that 1. That means you can assume it is a masked image. So let's check the original dataset. It also say it is a masked image. That means our model is good at the prediction. Let's give the another image. You can see it gives some values which is in the scientific notation. For decoding this scientific notation, I'm going to this website and put the value here. So you can see this value is almost equal to 0. It means this is not a masked image. So let's check with this data with the original data set. You can see our model says it is not a masked image. So that's all about this video. If you like this video, give a like and subscribe and share for more interesting scripts in Python. Thanks for watching and thank you. See you on next another video.